Now the question over here is n queens 2. It's a build up on n queens, which was 51, which I've done. So if you have not watched that video, I recommend watching that video first because I will skim over this quickly. So it's the same thing. The concept is the same. We have a positive diagonal set and we have a negative diagonal set. In this, we will also have a variable count because this is what we have to return. We are going to initialize it with the value 0 to begin with. We do the same thing, backtracking like we did in n queens. Whereas in this, we are going to assign it a value non-local count because if we don't assign it the value non-local count, then it will, if when it's running the backtracking function, it will think that okay, count is local to backtrack, but that's not the case. And it will look when it comes to assignment over here, when we are increasing the value of count, it will check for local count and it will say that okay, it has never been given a value because we assigned it outside the function in total n queens, and it can crash. Therefore we declare it non-local count. So we're telling our backtracking function the count is not your value, it's not local because it's been given a value over here outside the function. So yeah, non-local count when row equals to n, which means when we are at the last row, we increase the count by 1 and we return. And this is the same if columns, if call in calls, row plus call in positive diagonal or row minus call in negative diagonal, we are going to continue. Then we do the same thing, which is add, then recurse, then remove, and then we call the backtrack at 0, which is the first index, 0th index, and then we return count because this is what we want to return. So yeah.